Hello, Mr. Fry's Geometry. This is March 19th. I'm looking at the Chapter 12 notes, taking a look at these, just kind of going through them with you. Get them down if you don't have them and get them turned in if you need to do that. So, an experiment is an action or a trial with varying results. An example would be rolling a die. The outcome is a possible result from the experiment. The example would be two, like flipping a coin. Sample, so here's a sample. The set of all possible outcomes, rolling the dice. Outcome, I'm sorry. The outcome, the possible result, like a possible, you rolling a two, rolling the die. We're sticking with rolling a die here, sorry. The set of all possible outcomes, you could either roll a 1, 2, 3, 4, 5, or 6. Drawing the tree here, picking a digit 1 through 8, and then tossing a coin. So first of all, you have the opportunity to pick a digit, like out of a hat. There's numbers, and there's the digits 1 through 8. Okay, so you pick, and then you're going to flip a coin, heads or tails, right? So here's the tree for that scenario. And your samples, you could pick a 1 and then flip a heads. You could pick a 1 and flip a tails, and so on and so forth. Okay. So there are 16 things going on here. We just take the 8 times the 2, and there's 16 different outcomes. For this number 2, randomly guessing the answers to the last 3 multiple choice questions on a test if there are 4 options. So you have 3 multiple choice questions, and then you have 4 options for each. So we're just going to take that 3 times the 4, and you get 12, and you can see your sample, your outcomes there. All right. This one, choosing, and hopefully you're pausing this as we're moving forward, choosing a day of the week and then choosing a letter from the word math, M-A-T-H. So there are 7 days of the week, right? And so you're either going to pick, Sunday, Monday, Tuesday, Wednesday, Thursday. That's these notes down here. And then once you pick that, then are you going to pick an M, an A, a T, or an H? So we take the 7 times the 4, and we get 28. And here's a list of all of the possible outcomes. Okay, you can use the counting principle to find the total number of outcomes. If one activity can occur in M ways and another activity can occur in N ways, then both activities can occur in M times N ways. So let's get on it. So you can see all these listed here for you. Choosing a month of the year and a digit 1 through 9, just 12 times 9. Choosing a letter of the alphabet and then tossing a coin. There's 2 sides of a coin. There are 26 letters in the alphabet, so 26 times 2. Choosing a pair of pants, a shirt, and a belt from 3 pairs of pants, 5 shirts, and 2 belts. So you just multiply those 3 pants, 5 shirts, and 2 belts. All the possible combinations you could have would be 30. Rolling a standard die 4 times. So you could get, there's 6 possible, 6 possible, 6 possible, 6 possible times 4, and 6 times 6, 4 times, or 6 to the 4th power, 1,296 possible outcomes. Choosing one student from a class of 32 students and another student from a class of 27 students. So we just multiply those together. Spinning the spinner to the left, this one, 1 through 16, 3 times. So you're just going to take the 16 to the 3rd power. Tossing a coin 5 times. There's 2 sides of a coin, so 2 to the 5th power is 32. Creating a 4-digit password from the digits 0 through 9. So 0, counting 0 through 9, there are 10 digits. So there's 10. So there's 10 there. And then to create a 4-digit password, that would be 4 times that 10. Or 4 times you're going to multiply 10. So 10 to the 4th power is what I'm trying to say. So you have 10,000. Choosing a perfect square number that is less than 50, then a letter from the word signature. So perfect square that is less than 50. There are 7 of them, and a letter from, then choosing a letter from the word signature. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9, so 7 times 9 gives you that 63. Okay, probability is a measure of the chance that a specific event will occur. And when all the outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. So, probability of the event is the number of favorable outcomes divided by the total number of outcomes. All right? So probabilities have ratios between 0 and 1 and can be expressed as a fraction, decimal, or percent. Okay, so that's when they're going to be expressed as a decimal between 0 and 1. So the spinner below is spun once. Find each probability as a fraction in simplest form, a decimal, and a percent. So a multiple of 3. Well, there are 5 multiples of 3 between 3 and 16, so that would be 5 out of 16. You just put this in your calculator. How did I get this decimal? Do 5 divided by 16. That's all you're going to do. So you're going to do 5 divided by 16. You get that 0.3125. In order to change this to a percentage, all I'm going to do is move the decimal through 2 places to the right, and you have 31.25, so 31.25%. A prime number, there are 6 prime numbers on this, and so we're going to go with 6 out of 16, and we are that's going to be 3 out of 8 to simplify it, and here are your decimal and percent. Even number greater than 5, any even number greater than 5, so we have those here, so there's 13 of them all together, and so that would be 13 out of 16. And then odd and at most 9. So it has to cover both, so that would be 5 of those out of 16. And here you have the same decimal and percent as in A. Okay. We have a pencil box, contains 5 red markers, 12 blue markers, 10 green markers, and 3 yellow markers. If a marker is chosen at random, what is the probability that it is not yellow? Okay, so adding all those up, we have 30. Not yellow would be 27 out of 30, and that would be 9 out of 10. Simplified it, dividing both the numerator and the denominator by 3. What is the probability of drawing an ace or a diamond from a standard deck of playing cards? That would be 16 out of the 52. Standard deck of playing cards has 52. An ace or a diamond would be 16 of those, and that is going to be 4 out of 3 when we divide both the top and the bottom by 4. Finn guessed on the last 3 true or false questions on his math quiz. What is the probability that he got exactly 2 questions correct? Okay, exactly 2 questions, not at least 2 questions, but exactly 2 questions. So it's either going to be, correct, correct, incorrect, correct, incorrect, correct, incorrect, correct, correct. Okay, so that's going to be 3 out of 8 because we have true or false. That's going to be 2 of them, and those out of those scenarios. So you can go true or false. So we have 1, 2, 3, 4, 5, 6, 7, 8. So if you develop a tree on that, it's a little bit easier to see. So you could get either correct or incorrect for the true or the false. Okay, so there's your 8 possibilities, so 3 out of 8. Number 5, 2 standard dice are rolled. What is the probability that the sum of the 2 dots on the dice is at most 5? Here are all the possibilities, and that would be 10 out of 36. Or if you divide both the top and the bottom by 2, you get 5/18. Students in a homeroom were asked if they have a part-time job and if they have their driver's license. The results are shown in the Venn diagram to the left. If a student from the homeroom is chosen at random, find each probability and give your answer in the fraction in the simplest form. So part-time job here, part-time job. So we have 8 and 6. Don't forget about this because these are part-time job and a driver's license, but they still have a part-time job. So 8 plus 6 is that 14 out of the total. All students would be 25. So 14 out of 25. No driver's license. No driver's license would be these people with a part-time job and just these people that don't have a part-time job or a driver's license. So that would be 12 out of 25. Part-time job and a driver's license. That's in the middle of that Venn diagram. That's the 6. They have both. They're in both circles. So that's going to be 6 out of 25. Part-time job or a driver's license. Part-time job or a driver's license. And they could have both. So that's 15 plus 6, 21. So 21 out of 25. Driver's license and no part-time job. That's just that 7 there. So that's why it's 7 out of 25. We have out of 60 students, 15 are taking calculus and 27 are taking physics. 8 of the students are taking both calculus and physics. If a student of this group is chosen at random, find each probability. So here we have this drawn over here. Takes calculus or physics. Calculus or physics, adding those up. Out of the total number is going to be 34 out of the 60. So that's 15 plus the 19 there. That's 34 out of 60. If we divide both by 2, you get 17 over 30. Takes calculus but not physics. Takes calculus but not physics. That's 7 out of the total number, all these numbers that are in that whole box. So that's 7 out of 60. The complement of an event is the probability of an event not occurring. And since the sum of all probabilities in a sample space is 1, or 100%, the probability of an event not occurring is P, and then you have that little squiggly line and then the event. And that equals 1 minus the probability of the event occurring. So the probability that it will rain tomorrow is 11 out of 15. What is the probability that it will not rain? You could also think of this as, total probability is 15 out of 15, 100%, okay? Minus 11 out of 15, and that's going to be your 4 out of 15. So you could think of it that way. A number from 1 to 30 is selected at random. What is the probability of not selecting selecting a multiple of 4? Okay, so there are 7 multiples of 4, 1 through 30. So that would be 30 minus the 7 would give you the 23. And then experimental probability is based on the result of repeated trials of an experiment. For example, the spinner at the right is spun 50 times and the results of the spin are shown in the table. So the actual thing happening, that's experimental, okay? So theoretically, orange is just 1 out of the 5, right? So 1 out of 5 is theoretical. But experimental orange, actually, it was rolled 12 out of the 50. So 12 out of the 50 reduces down to 6 25ths if you divide both the numerator and denominator by 2. Red or green. So red or green is 2 out of 5. Actually, it was 5, so the experimental, 5 and green 10, so 15 out of 50. Divide both top and bottom by 5, you get 3/10. And not purple, anything, but purple, so that would be, 1, 2, 3, 4 out of the 5 would be not purple. And actually, that would be 5 plus 12 plus 16 plus 10, that's 43 out of the 50 are not purple in the actual experimental probability. Okay, I think for homework, for tonight, you actually just had to do 7, 8, and 9 on your own, so hopefully that helped. And I'll have for some of your other work, I'm going to have a video posted right along with this.